The rate of a chemical reaction is influenced by several key factors that govern how quickly reactants transform into products. Understanding these factors is essential for both academic study and practical applications in fields such as chemistry, engineering, and even environmental science. The four main factors affecting the rate of reaction include concentration, temperature, surface area, and the presence of catalysts. Each of these factors plays a crucial role in the frequency and energy of collisions between reactant molecules, which ultimately determines how quickly a reaction proceeds. Let's begin with concentration. In a chemical reaction, reactants must collide with one another to form products. When the concentration of reactants increases, the number of molecules in a given volume also increases. This higher density of reactant molecules leads to more frequent collisions. Imagine a crowded room where everyone is trying to talk to each other. The more people there are, the more conversations happen at once. Similarly, in a chemical context, more collisions mean a greater chance for reactions to occur, thereby increasing the rate of reaction. This relationship is particularly evident in solutions, where the concentration of reactants can be manipulated to achieve desired reaction speeds. Next, let's discuss temperature. Temperature is a measure of the average kinetic energy of molecules. When the temperature rises, the kinetic energy of the reactant molecules also increases, causing them to move faster. Faster-moving molecules collide more often and with greater energy. This increased energy is crucial because not all collisions result in a reaction. Only those that occur with sufficient energy to overcome the activation energy barrier will lead to products. Therefore, as temperature increases, the number of effective collisions rises, leading to an accelerated rate of reaction. This is why many reactions are carried out at elevated temperatures, to enhance the speed and efficiency of the process. Now, let's consider surface area. The surface area of a solid reactant is an important factor, especially in heterogeneous reactions where reactants are in different phases, such as a solid and a liquid. When a solid reactant is broken into smaller pieces, or when it is in powdered form, the surface area exposed to the other reactants increases. More surface area means more sites available for collisions to occur. Think of it like trying to paint a fence. If the fence is solid, you can only paint the surface you can see. But if you take it apart and lay it flat, you can cover much more area at once. In the same way, increasing the surface area of a solid reactant allows for more collisions and, consequently, a faster reaction rate. Lastly, we have catalysts. Catalysts are substances that increase the rate of a reaction without being consumed in the process. They work by providing an alternative reaction pathway with a lower activation energy. This means that more collisions will have sufficient energy to result in a reaction. A catalyst essentially lowers the threshold that reactants must overcome to react with one another. It's akin to creating a shortcut through a mountain. Instead of having to climb over the peak, you can take a winding path that makes the journey easier and quicker. Catalysts are invaluable in both industrial processes and biological systems, where they enable reactions to occur at rates that would otherwise be impossible under normal conditions. In summary, the rate of a chemical reaction is influenced by concentration, temperature, surface area, and the presence of catalysts. Each factor affects the frequency and energy of collisions between reactant molecules. By manipulating these factors, chemists can control reaction rates, leading to more efficient processes and better outcomes in various applications. Understanding these principles not only enriches our knowledge of chemistry, but also empowers us to harness these reactions in practical, real-world scenarios.